All right, let's get right into it. We are about to pull back the curtain on one of the most, let's be honest, kind of confusing rules in math, that one rule you were probably just told to memorize, no questions asked. Well, today, we're not just going to learn the rule. We are going to finally understand it.
You know exactly what I'm talking about, right? It feels a little like a magic trick. You've got this division problem, you flip the second fraction upside down, you swap the sign for multiplication, and poof, the right answer just appears. But why? Why does that one little flip do the trick? Let's finally get a real answer.
Ah yes, this old chestnut. This is the answer pretty much all of us got. And it's so frustrating because it's not really an answer at all. It makes math feel like you're just memorizing a bunch of weird spells instead of, understanding a logical system. So today, we're going to break that spell for good.
So to really get to the bottom of this whole thing, we can't start with the rule itself. Nope, we have to go deeper. We have to start at the very beginning and ask a much bigger question. What is division? Actually, what's it for?
Okay, this right here, this is the master key to everything. Seriously, forget about sharing cookies for just a second. At its absolute core, a problem like a divided by b is just asking a question. It's asking, hey, what number, we'll call it q, do I need to multiply by b to get back to a? See? Division isn't its own thing. It's just the reverse of multiplication. It's all about finding the missing piece of a multiplication puzzle.
So before we tackle the big one, let's put this missing factor idea to the test. Let's try it on a problem that we can solve with just plain old intuition. No flipping, no magic tricks, just logic. So have a look at this problem. 6/7 divided by 2/7. Now, because the denominators are the same, they're both sevenths, we can think about this really simply. It's like asking, if you have a bar that is 6/7 long, how many little 2/7 chunks can you fit inside it?
Yeah, it's just 3. You can literally count them. One 2/7 chunk, a second one gets you to 4/7, and a third gets you to 6/7. The answer is 3. See? No inverting, no multiplying, it just makes sense.
So there you have it. Our big idea works perfectly. We just found the missing factor, and there was no magic needed at all. Now that we've got our sea legs, let's use this exact same thinking to build the famous invert and multiply rule from the ground up.
And we're going to do this with a clear 4-step game plan. First, we'll rephrase the problem using our big idea. Then we'll state exactly what our goal is. Third, we'll find the perfect tool for the job. And finally, we'll use that tool to get our answer.
Okay, step 1. Here's our generic fraction division problem. Don't let the letters scare you. Using our definition, we can just rewrite it. Instead of saying a over b divided by c over d, we're going to ask c over d times what? What number q equals a over b? That's it. Our entire mission from here on out is to find q.
Which brings us right to step 2. What's our goal? Well, it's super simple. To figure out what q is, we need to get it all by itself on one side of that equal sign. We have to somehow peel off that c over d that's currently being multiplied by it.
So, how are we going to do that? Well, let me introduce you to our secret weapon, the reciprocal. You probably know it as just flipping a fraction, but its real superpower is that when you multiply any number by its reciprocal, the answer is always 1. And multiplying by 1 is basically like doing nothing, which is exactly what we need.
And this is why it's the perfect tool for our mission. Look here, the reciprocal of c over d is just d over c. When you multiply them, everything cancels out and you're left with a nice, clean 1. This is the key that's going to make that fraction basically disappear from the side with our q.
And here we go, the final step, the big moment. To keep our equation fair and balanced, whatever we do to one side, we have to do to the other. So we multiply both sides by that reciprocal, d over c. On the left side, it turns into a 1, leaving our q totally alone. And on the right side, just look what happened. q equals a over b times d over c. We did it! We just derived the invert and multiply rule. It's not magic, it's just logic.
So you see, that rule isn't some random instruction somebody made up. It's a shortcut. It's the fastest path you find when you're just trying to solve for that missing piece. It's a shortcut built on pure meaning. Let's walk through one more example to really lock it in.
Okay, let's take 2/3 divided by 5/6. First, we rephrase it. 5/6 times what gives me 2/3. Then, to get our missing number alone, we use our tool. We multiply both sides by the reciprocal, which is 6/5. And boom, you do the math, and the answer is 4/5. Every single step has a clear why behind it. This is the huge mental shift. Instead of your brain saying, okay, I flip because that's the rule, now it can say this. You're not just blindly following a procedure anymore. You are strategically picking a tool, the reciprocal, to reverse an operation and find what's missing. That feels totally different, right? It's powerful. And that really is the biggest idea of all. It is 100% okay to use shortcuts like invert multiply. That's why they exist, to make things faster. But it's so much more powerful when you know they aren't just arbitrary spells. They are discoveries, beautiful properties of how numbers work, all built on a solid foundation of logic and meaning.
So, the next time you run into a math rule that feels a little weird or magical, I hope you get a little curious. I hope you ask, wait a minute, why? Because odds are, there's an amazing, logical explanation just waiting there for you to find it. And who knows what other rules you could uncover for yourself.